In this video, we're going to be continuing solving some logarithmic and exponential related problems. So let's start off with 12 here. So what can we do here? We can rewrite this as we can just divide both sides by 8 here, or negative 8. See? Now you just have log b is going to equal to 8. And then when we have this, when you have something that's just, when you can't see the base, you can't see like the little number underneath it, it means it's 10. So then you can just rewrite this as b is equal to 10 to the power of 8. So then this number becomes the number that you raise something to. And 8 is going to be the thing that you raise to the power of. And b is the thing that's like equal to it. So yeah, that's basically it. So, and here we know b is going to be greater than 0. So let's move on to the next one. So here we can subtract 2 from both sides, and then you're just left with 3 log 3d is equal to 3. So then you divide both sides by 3, then you have log 3d is equal to 1, then you have 3d is equal to 10, then you have d is equal to 10 over 3. So now let's move on to the next one. So now we have 100 plus 500 log 1g is equal to, log base 1g is equal to 1100. So what are we going to do? We're going to subtract both sides by 100. Then you're left with 500 log 1g is equal to 1000. So again, divide both sides by 500. Then you have log 1g is going to equal to 2. So then now we can write this as 1 to the power of 2 is equal to 1. So g could equal 1. But we have no solution because base 1, we define the log function as y is equal to log base bx to say b is greater than 0, and also that b is not equal to 1. So now, and that's because, let's write this over here. B is greater than 0, g is greater than 0, and also x is greater than 0. So let's move on. Log base 5 x is equal to log base 5 x plus 6 minus log base 5 4. So what can we do here? Well, let's just isolate all the logs to one side. So now we have log 5x plus 6 minus log base 5 4 minus log 5x is equal to 0. So now you have log 5 x plus 6 divided by 4x, and that's just going to equal to 0. And also remember that x has to be greater than 0 because we want the input, the argument. It has to be positive because that's just the requirement of logs. So then we have 5 to the power of 0 is just going to be x plus 6 divided by 4x, and then we have 4x is equal to x plus 6, and then so this is just equal to 1, and then you multiply both sides by 4x. That canceled out. So here you have 3x is equal to 6, and then divide both sides by 3x is just equal to 2. Great. So now let's move on to the next problem. What can we do here? So first thing we can do is we can do some u sub. We see this term here, it repeats a lot. So what we can do is just, try to get rid of that so we can focus on something else, because we can see that this is a quadratic form that we can rearrange it as. So we have u is equal to e to the power of x. It's going to be 9u squared minus 3u minus 6 is going to equal to 0 after just subtracting 6 from both sides. And now we're going to have 3 times 3u squared minus u minus 2. Because we can factor out the u, so now we can shift this 3 here, so it's going to be u squared minus u minus 6 times 3. Just move this over here. So now what we have is u minus 3, u plus 2, because negative 3 plus 2 is just equal to negative 1, and now we have to dividing it by 3, so you're gonna have 3u plus 2, and you're gonna have u minus 1 times 3 is equal to 0. So what do we have? We set each of our factors equal to 0, so we're gonna have negative 2 3u divided by 3, u is equal to negative 2 over 3 as one of our solutions, and then we have u minus 1 is equal to 0. Adding 1, we have u is equal to 1. And what do we have here? So we have e to the x is going to equal to negative 2 over 3 and 1. So we have to plug back in, because earlier we substituted u is equal to ex, and this is not our final form, so we had to sub this back. So e to the x is equal to negative 2 over 3, or e to the power of x is equal to 1. But do you see what's wrong here? Well, this is negative. And what do we define the input of this? I mean, why, like, x, it just can't be negative, okay? So we know this is extraneous. This is not a log. It doesn't have inputs. It's exponential. So e to the x, this is also, x is equal to 0. So, or, yeah, okay. So let's solve this one. What should we do here? So first thing we can do is, so we have ln 4x squared minus 3x plus ln x minus ln 16x minus 12 is going to equal to 0, isolating everything on one side. So next, after this, we can do ln, well, we see things are being added and subtracted here, and everything is ln, so it's a common base. So the first thing we can do is remember that plus is basically like multiplication, subtraction is basically division, or if you remember our log rules. So what we're gonna do is we're gonna multiply all the things that are being like added here. So we're gonna do x times 4x squared minus 3x. Then we're gonna divide that by the thing that we're subtracting here, which is 16x minus 12. Right there, nice and neat looking. That's gonna be 0. Then after this, you're just gonna FOIL this. That's gonna be, and if we can also raise both sides to the power of e, so that we can cancel this, because this is an e right there, and then when there's an e here and there's an e here, and you have like a log right here, this just cancels out. That's the rule of logs. And e to the power of 0, that's just gonna be equal to 1, so then you can actually change this into 1. This is gonna FOIL to 4, or just like multiply, distribute 4x to the power of 3 minus 3x squared, and then dividing this is 16x minus 12. So then what do we do after this? Well, we can multiply both sides by 16x minus 12. See, nice, 16x minus 12. So then, multiply that out. Okay, yeah, you're gonna have to, this just cancels. Yeah, so you're gonna have, this is just the same thing. Minus 12 is equal to 4x to 3 minus 3x squared. Yeah, you can just subtract this. Add that. Minus 16x plus 12. And then we're gonna be left with 4x to the power of 3 minus 3x squared minus 16x plus 12 is equal to 0. And then we can factor by grouping here if you just focus on these components right here. So you're gonna have, you can factor out an x squared here, and also you're gonna be left with 4x minus 3, and then here you can factor out a negative 4 from 16 and 4. Negative 4 is a common factor, so you're gonna have 4x minus 3 is equal to 0. So now what can we do here? So remember, after this, these two have to be the same. That's good, that was the same. And then you just take whatever is left over, and then that becomes the other factor. So this is gonna be x squared minus 4 times 4x minus 3 is equal to 0. And this was the blue thing. You only take one of those. So this factors down into x plus 2, x minus 2, 4x minus 3 equals to 0. X is going to be equal to negative 2, 2, and 3 over 4. But this is extraneous, and also this is extraneous. Because, and we'll prove that. Sorry. So x is equal to 2 is the only solution, and the reason why is because we can create this number line right here, and then we have, again, we had x, 4x minus 3, and that has to be greater than 0. And we can split up this number line into 0, 3 over 4, and then we also have x is less than 0, and also x is greater than 3 over 4. And also, okay, yeah, and the reason where we get all those is from, actually, let me put this specifically under, so this is from there, but like, let's reproduce this. Actually, let's just rewrite this here. So ln 4x, okay, so here's what you're gonna do when you do these types of problems. Ln 16x minus 12 minus ln x. So basically, what you do is, like, you see this right here, you're gonna have to take each of these, and then this factors down into x, 4x minus 3. That's the input, right? This is the input right here. So this has to all be greater than 0. That's a requirement. And then over here you have 16x minus 2. Well, this just boils down to x has to be greater than 3 over 4. And also here, this x just has to be greater than 0. So now we create this number line, and then we can say that this is on the positive side, and this is a negative, and then this is positive. So that means that we have x greater than 0, and x is also, x is less than 0. X is less than 0, and also x is greater than 3 over 4 as positive component parts. So that means it's not including 3 over 4, so that's why we eliminated 3 over 4, and that's also why we eliminated negative 2 as well. So, okay, we're back. So let's do this problem. So we have g of x is equal to x plus 6 divided by x plus 3, x plus 5. So what can we do here? So we know that the horizontal asymptote is just gonna be y is equal to 0. And why is this the case? Well, that's because the degree of the numerator is less than the degree of the denominator, because this is 1, and then this is 1. Because the highest degree term in this inside of the parentheses is gonna be x, and x is a linear term. So these are just 1. So then to find the degree, you just do 1 plus 1 is equal to 2 is equal to the degree. Well, I don't know. I'll just write degree. Up here is just equal to 1. Okay, yeah. Okay, that was a little long. But yeah, that's the horizontal asymptote. And the vertical asymptote, how do you find the vertical asymptote? Well, you set each of the things in the denominator equal to 0, and you solve for x. So then you have x plus 3 is going to equal to 0. That's going to be x is equal to negative 3. And then you have x plus 5 is equal to 0. And then that's going to be x is equal to negative 5. And what is the domain? So, well, we know the domain is going to be from negative infinity to negative 5, union negative 5 to negative 3, union negative 3 to infinity, because we want no vertical asymptote. So we cut the vertical asymptotes out of the domain. So also remember, like, if you have to remember which one you cut out, do you cut out the vertical asymptotes or the horizontal asymptotes from the domain? So remember, vertical asymptotes are cut out of the domain, and then horizontal asymptotes are cut out of the range, because it boils down to x versus y. So it's kind of like the opposite, horizontal, vertical domain. So okay, so now let's do another one. Yeah, so let's do this. G of x is equal to 2x plus 3, x minus 6 divided by x plus 2 divided by x minus 1. So we are going to find the asymptotes and the intercepts, and then we're also going to graph, and we're also going to state the domain. So let's do this. So the domain, we'll do that afterwards. First of all, the horizontal asymptote, what can we see here? That's 1, 1, 1, 1. So the horizontal asymptote is going to be the same. So the numerator and the denominator have the same degree. 2 is equal to 2. And what we're going to do now, well, when that happens, that means that the horizontal asymptote is equal to the ratio of the leading coefficients. So that's y equals a over b, and the leading coefficients is just going to be 2, and then here it's just 1 because there's just like nothing. So it's going to be 2, y is equal to 2. And then for the vertical asymptotes, we can see it's already factored. So then again, you said x plus 2 is equal to 0, and then x minus 1 is equal to 0. X is equal to 1, and x is equal to negative 2. So then we have those as our vertical asymptotes, and then now let's do the x-intercepts. So in order to do the x-intercepts, well, what you're going to do is you have to set the things in the numerator equal to 0, and you're basically going to solve. So the factors. So that's going to be 2x plus 3 is just equal to 0, and also x minus 6 is equal to 0. So that much, right? 0. X is equal to 6, and then 2x is equal to negative 3. Divide this by 2. X is equal to negative 3 over 2 and 6. So then you can write these as points as negative 3 over 2, 0, and also 6, 0. So now let's find the y-int. So in order to find the y-int, set x equal to 0. Set y equal to 0 here. So what this means is, yeah, basically you take your whole entire thing, you have like y's here, then you have 2, 0 plus 3, 0 minus 6, divided by 0 plus 2, 0 minus 1. So we're gonna have here, you're gonna have 3, that's just 0. I'll just keep it there. And then this is gonna be negative 6, and then this is gonna be 2, and then this is gonna be negative 1. 3 times negative 6 is negative 18, divided by negative 2, that's gonna be equal to 9. So that means the y-intercept is, y is just equal to 9. So that's a y coordinate. So then you're just gonna have 0, 9, because the x value that we plugged in was 0. So that's x equals 0, and then y is equal to 9. So 0, 9 is the coordinate point. So now after this, we have to, in order to find the domain, well, we have to create another sign analysis. And to do sign analysis, you basically take you make like the number line, and then you have to you have to mark the points. You have negative 2, and you have negative 3 over 2, and then you have 1, and then you have 6 here. So basically, we're gonna create like fractions. We're gonna substitute in random numbers, like any number inside of the range that's like inside of like the thing we divided up into, and we're gonna test some points. So let's test a point here. So let's do like negative 3. So imagine if we do like negative 3, we're gonna have negative 3. So 2 times negative 3 is gonna be negative. Should we just write this out? That's gonna be negative 6. Negative 6 plus 3 is still gonna remain negative. So, and if you do negative 3 times, what am I saying? Negative 3 minus 6, that's gonna be also still negative. And then if you do negative 3 plus 2, that's still gonna be negative as well. And then if you do negative 3 minus 1, that's still gonna be negative. So this is just gonna be negative times negative times negative. Blah. So that's just gonna be, the result of that is gonna be positive. And then, okay, over here, let's do negative 1. So imagine we have negative 1. So 2 times negative 1 is gonna be negative 2, plus 3 is 1. So that's gonna be positive, or hold on, 2 times negative 1 is going to be negative 2 plus 3. That is positive. But that's not, negative 1 is not in that interval. Oh, this is negative 1.5. Okay, so this is, okay, negative 1.75. You can imagine that. So that's going to be negative, negative, positive, negative. Okay, so then the result from that's going to be negative. Okay, the result from this will be positive, negative, positive, negative. This is going to be positive, negative, positive, positive. This is going to be positive, 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 positive. This is going to be the result from this. That's going to be negative. That's going to be positive. That's going to be negative. That's going to be positive. All right, so now we can just graph this. Like, to graph this, it's gonna create, like, you know, this, just mark things up. So what do we do first? Well, I guess we can start with our vertical asymptote. So we have a vertical asymptote at x is equal to 1. And also we have a vertical asymptote at x is equal to -2. That's a thick pen. Okay, my bad. We have an x-intercept at -3 over 2, 0. So that's going to be like over here. And we have another one at 6, 0. So 1, 2, 3, 4, 5, 6 right there. So we can kind of see that. And the reason why we stopped above there, well, we have a horizontal asymptote at y is equal to 2. And we also have y-intercept at 0, 9, 3, 4, 5, 6, 7, 8, 9. So we can put that there. And yeah, so those are our asymptotes. And now we're kind of like, we have these, but remember the asymptotes can the graph can actually cross asymptotes in the middle, but it's just like the asymptotes are end behavior, but what happens in the middle of the graphs isn't really like strictly like prohibited, like, and it doesn't like confine it, so it can actually cross over. So how do we know like which side the graph is on either side of the asymptotes? Well, we know from here, from doing the sign analysis. That's why we did it up here. So we know from -infinity to -2, it's going to be on the positive side of the asymptote. So that means we know it's going to be on this top side here. And then over here, we know it's going to be from here to up here, because we know here it's going to, from -2 to -3 over 2, it's going to be on the negative side, but then it crosses, it's no longer negative here, because then it goes positive from -3 over 2 to 1, and it's positive, see there? And then over here it was negative, and then it goes back up. So that's basically like, just like look at the big picture of this analysis. It's really cool. Right, so let's do another problem. Actually, we're going to be continuing with some logs. So let's evaluate some basic logs. So what does this mean? Log base 216 is equal to x. So you're going to, basically when you see this, you have to set it equal to x, and then you're just basically going to be solving for what x is. So rewriting this is just 2 to the power of x is equal to 16. So what do you raise to the power of, what do you raise 2 to the power of to get 16? Well, you raise it to the power of 4 to get that. So that means x is just equal to 4. So here you set it equal to x again, and then you have 3 to the power of x is equal to 27. So x is just going to equal to 3, because 3 to the power of 3 is, okay, let's just write that there. 3 to the power of 3 is equal to 27. So let's move on to the next part. So here, what can we write? So 2 to the power of x is equal to 2 root 2. So 2 to the power of x is equal to 2 to the power of 3 over 2. So x is just going to equal to 3 over 2. What do we do here? So this is equal to x. So what do we have here? 1 over 8 power of x is equal to 2. And then 1 over 8 power of x is equal to 1 over 2 to the power of 3 is equal to 1 over 8 to the power of -3. And then so x is just going to equal to -3. What do we do here? So again, we have something that is a fraction. So when you have a fraction, you want to flip it. So when you flip it, you have, okay, so here we can write this as 3 to the power of x here, right? And then we set it equal to this. So you have 1 over 81. So how can you rewrite 1 over 81? Well, that's just 1 over 3 to the power of 4. And how can we just rewrite this? We can just rewrite this with a negative exponent. So then we can see that the bases are the same here, so they basically cancel out. And then you can just focus on the exponents, then x is just equal to -4. Well, over here, what do we have? We set this whole expression to x, and then we rewrite it again. So again, we have the same process. That is going to be 3 to the power of x, and this is going to be equal to the argument inside. So 27 over root 3. Remember, that's the argument, and this is going to be the other stuff over there. Okay, this is a decimal point. That, yeah, because that's 3 to the 1/2, and then, yeah, that makes more sense. So then these bases cancel out, then it's just x is equal to -7 over 2. So over here, well, we see this is expression is equal to x, and then we have 5 to the power of x is equal to 5 times the root of 625, because this is going to be 5, that's x over there, this input right here. Okay, so now this can be rewritten as, we know 625 is going to be 5 to the power of 4. And remember that the root thing, you always do 1 over the number that is in the root thingy. So that's in the root thingy, so it's over there. So then you have 5x, and then, okay, so now over here, what we can do is, since we have that, we can just multiply that there. So that's just like 4 over 5, but let's make that look more like this. And, okay, so yeah. So this is be 5 to the power of x, then x is just equal to 4 over 5. Because again, remember, you always have to cancel that base out. You don't need that base. Okay, over here, so now we see log base root 2. Okay, square root of 2 is equal to x. So then we have square root of 2 to the power of x right here. And then that's going to be equal to the argument, which is just 16. So now that we have this, the first thing we can do is we can convert the square root of 2 into 2 to the power of 1/2. And then we can keep it to the power of x, and then also can get a base of 2 over here. So now here we can just ignore the bases because they're the same. So now we have 1/2. Multiply those together, 1/2 x is equal to just 4. And then multiply both sides by 2, reciprocal that. Well, that is just going to be x is equal to 8. Now let's go down here. So basically we have this. And you're going to set this equal to x. And then 4 to the power of x is equal to 8. Again, we've done this a couple times. And then you have 2 to the power of 2 is equal to the power of x is equal to 2 to the power of 3. 2x is equal to 3. X is equal to 3 over 2. Here, this is going to be equal to x. This is going to be 3 root 2 to the power of x is equal to square root of 2 to the 4th. And then this is going to be 2x over 3 is equal to 1 over 4. And you can see that the bases are the same here again. So that's just going to be x over 3 is equal to 1 over 4. Multiply both sides by 3 to cancel that out. So now you just have x is equal to 3 over 4. And now we can move on to our next problem. So here, this is going to equal to x. We're going to have 1 over 9 to the power of x is equal to 27. And then now what we can do 9, we know that's a perfect square. So that's 1 3 squared to the power of x is going to equal to 3 to the power of 3. So then we can flip this because we know we can just make this into a negative exponent instead. Negative 2x, and we have to keep, we have to multiply the power of x as well. And keep it times negative 2. So 3 to the power of 3, same bases as you know. So this is going to be negative 2x is equal to 3. X is equal to negative 3 over 2. Now over here, this is going to equal to x. And then we're going to have root 5. So the power of x is equal to 125. And then 5x over to the power of x over 2 is equal to 5 to the power of 3. Again, these bases are the same. So that's going to be x over 2 is equal to 3. Multiply both sides by 2. That is just equal to 6. Now down here, what do? So basically you can rewrite this as 2 to the power of